Start with the chapter the antigen. The antigen is a microorganism, or it is any substance which evokes an immune response in the host to produce specific antibodies, which in turn will react with the antigen to cause their destruction. Coming to the types of antigens, there are two types, that is complete antigen and incomplete antigens, which are also called as haptens. These haptens can be divided into simple and complex types. Coming to the complete antigens induce the antibody formation by themselves only, while the incomplete antigens cannot directly induce the antibody formation, but they require certain carrier proteins are required by them. They require certain carrier proteins for the induction of the antibodies. But remember that the already induced antibodies, suppose if the reaction is secondary, that is if it is taking place by the second time, then those antibodies which have been already induced in the body can attack both the haptens, as well as it can even attack the carrier proteins also. uh, uh, and it is specific. What I mean by hapten is a specific hapten they can attack, and a specific carrier protein they can attack. Coming to the simple haptens are those which, when combined with the antibody, will not produce any kind of a precipitation, and they are univalent in nature. And while the while the complex antigens are the ones which are having polyvalency. What do you mean by polyvalent? That is those which are having two or more antigen combining sites, that is they are having more antigenic determinants in them. They are called as the complex ones, and remember that these will produce the precipitation when combined with the antibodies. For example, the capsular polysaccharide of the pneumococcus. And coming to the pro antigens, these are those which are having lesser molecular weight. They cannot produce any kind of antibody, they cannot induce antibody formation, but certainly they can produce a delayed hypersensitivity reaction. For example, dinitro chlorobenzene, that is also called as DNCB. Coming to the concept of antigenic determinant, this is the smallest unit of antigenicity, is called as the epitope. And antigenic determinant is the site where the combining of the epitope as well as the paratope takes place. The paratope means the combining site on the antibody to the epitope, and usually the antigenic determinant will be 25 to 34 angstroms in size, and it will be having a lesser molecular weight only. Coming to the factors of antigenicity, the first factor is the foreignness, second one size, third is the chemical nature, fourth is the susceptibility to the tissue enzymes, fifth is the antigenic specificity, sixth is the species specificity, seventh is the isospecificity, autospecificity, organ specificity, and heterophile specificity. So let's discuss with the first one, that is the foreignness. And that means foreignness means the non-self antigens, non-selfness. Okay, the more and more is the if the substance is more and more foreign, then it will be more and more antigenic in nature. Remember that the body has a tolerance to self antigens because of the presence of, because of their continuous contact with the body during the development of the immune system. Okay, and antigen power will be more and more if the substance is more foreign. For example, the antigens of the different species will be more powerful antigens than the ones which are of the same species, of different individual. Coming to the size is directly proportional to the antigenicity, that is more is the molecular weight or more is the size of it, more antigenic specificity will be there. And the ones which are having lesser molecular weight, and particularly those which are having less than 10,000 molecular weight, will be either non-antigenic, or they will be weakly antigenic in nature. And these smaller ones, if they want to act, then they should be absorbed on the inert particles, like on the like they should be absorbed on the bentonite or kaolin. Coming to the chemical nature, the proteins except the gelatin will be more antigenic, and this property shown by the proteins is due to the presence of the aromatic amino acid, which is particularly tyrosine, and this will be very less in the gelatin. That's why it is non-antigenic protein. And lipids and nucleic acids will be less antigenic compared to proteins. And remember that the proteins are the naturally occurring antigens. Most of them are naturally occurring antigens. And coming to the susceptibility to tissue enzymes and metabolism, if they are susceptibility to tissue enzymes and if they get metabolized, then they will be certainly antigenic in nature. And the phagocytic cells enzymes will be helping in breaking down these antigens into smaller fragments. As a result of which they expose the unexposed antigenic determinants. Remember that the bovine serum antigen, that is the BSA, has 18 antigenic determinants, out of which only 6 are exposed while 12 are unexposed. So they need to be broken down in order to expose those antigenic sites. And remember that those which are non-metabolizable will be non-antigenic in nature. For example, the synthetic polypeptides like the D amino acids are they are non-metabolizable, and therefore they are non-antigenic also. Coming to the antigenic specificity, and this is directly proportional to the antigenic determinants, and the specificity will be shown in terms of the positional difference, like in the ortho, meta and para position, or in the spatial configuration, that is the dextro, levo and the mesoforms. But remember that this is not a very strict specificity, and sometimes even the cross reaction can also occur between the stereochemically similar ones.